considered. Okay, so the a question is that the first question which we have taken is that a photon behaves as it has a mass h mu by c, h mu by c square by h mu, or c h mu, right? These are the four options with us. Now my dear friends, you just need to remember that E is equal to h mu, right? Since why E is equal to h mu, it's often written as E equal to h mu because it's a fundamental principle of quantum mechanics which is introduced by Max Planck, right? What does it states? This E equal to h mu, it states that whenever energy of a single quantum means single photon, right? Photon, that means discrete, in they are having discrete level of energy in packets, right? So whenever a photon or single quantum is the energy of this of a photon is directly proportional to the frequency, where h is the proportionality constant, right? It is not, we can say that energy is not continuous but absorbed or emitted in discrete quantized level, right? Whole number of packets which are called quanta, right? So energy is distributed like this, right, in packets, right? All these are energies, right? These are the flow, like that, multiple packets, energy flow in packets only, right? Now this is the basic few things which you just understand or explained, where E is the energy, right? E is the energy of the respective photon, right? E is the energy, h equal to the Planck's constant, right? H is Planck's constant, which is known as, the value of which is around 6.626 into 10 to the power minus 34 joule second, right? This is Planck's constant, this is h, right? Now mu, mu is your frequency, that means frequency, that means we can say that frequency of the electromagnetic radiation, right, which is measured in hertz, right? So it is in hertz, or we can also say 1 by time, right, which is time, the unit of time is second, so 1 by second is hertz, right? This is the unit of frequency. Now what is quantization? Energy changes occur only in integer multiples, right? So the energy of a photon is just considered in integer multiple, either it 1 times h mu, right, or it becomes 2 times h mu, or it becomes 3 times h mu, right? Likewise, you can see these integers 1 multiplied by 1 multiplied by 2 multiplied by 3, but every time energy is equal to h mu, right? Here we can see E equal to h mu, right? Now considering this, if you just consider a photon behaves as it has a mass, right? Now the another equation which I want to bring into your, with the relation of mass and energy which is given by the Einstein, right? If you remember, E is equal to mc square, changing the pen, E is equal to mc square, right? Here the energy is considered for the photon, where the mass of the body is integrated, or that is in consideration, right? here Here m is the mass. It is a fundamental concept in physics stating that energy is equal to mass times the speed of the light squared, right? This is the speed of light. Now just let us relate this. E is equal to h mu, right? Let us say this is equation number 1. This is objective type question which is generally coming in, it is mostly, it will come in NEET only, right? But it can come in JE also. But anyway, let us see how this question can be solved. We know these two relations, Max Planck and Einstein relation, right? So using, if you equate equation number 1 and 2, then energy equal to h mu, right? Energy equal to h mu, and this energy is equal to mc square as per the Einstein, right? Now if you just consider both of these, right? Now a photon behaves as it has a mass. That means if you just consider this after equating h mu equal to mc square, then m can be written as, leave m into the RHS, it becomes h mu by c square, right? So you can see this option, h mu by c square is the m, or we can write m is equal to, just change the sides of the equation, h mu by c square. So which option is this? Tell me, which option is this? Option number second, right? Option number second. So mass of that photon will be equal to h mu by c square, right? Now just take the second equation for today. The second question for today. The second question is that the energy of a photon of wavelength lambda, right, is sc by lambda, sc lambda, sc by lambda, lambda by sc, or h lambda by c, right? So as we already discussed, right, E equal to h mu by the Planck's equation, right? You remember the Planck's equation, what Max Planck gives us is that E is equal to h mu, right? Your mu is the frequency, h is the Planck's constant, which is 6.626 into 10 power minus 34 joule second, right? Now this is frequency, this is Planck's constant, E is the energy. Now question is that the energy of a photon of wavelength lambda is what, right? So we know a relation E is equal to h mu, so we can write h mu, mu can be written as c by lambda, right? C by lambda. So this will give you E is equal to sc by lambda, right? So which option will be correct, my dear friends? Tell me, right? Option number 2 will be the correct option, right? So in this way, such questions, objective question, can be solved very easily, right? So yes, you just need to relate the things. Okay, what we related, E equal to mc square, right? That is the Einstein equation into the previous question, and E equal to h mu, which is given by Planck's constant, which is where the h is a Planck constant. Max Planck gives this equation, E equal to h mu, right? So these are the two equations or two formulas which we have considered and correlated with each other to come on the result, right? Thank you so much for watching, my dear friends. Take care. Bye bye. Happy learning.